Hello and welcome back to Kentucky Home Garage. My niece recently told me that I'm way too serious in my videos and I need to start smiling. So here comes on, I'm smiling, I'm doing my best. Okay, a couple of weeks ago I uploaded video on 2005 Honda CR-V with VTEC trouble code, and we replaced this unit with a solenoid and the pressure switch. We fixed the car. And a friend of mine who owns the car has been driving it for a couple hundred miles now, and the car is fixed. However, after I watched the video, I realized that I actually missed a couple of very important details in that video, and sometimes it is hard to get everything, you know, in your head and kind of talk about every single thing that you want to say, but later on you actually see something is missing. So in this video, actually, I want to kind of explain it more in the details what I was doing, and I'm going to leave a link in description to that video. So this unit has a solenoid and has a switch. Computer energizes the solenoid by applying the 12 volts to it. So it's a ground side switch, the power side switch. It's grounded all the time, so the computer sends a 12 volt to solenoid. Once the solenoid is energized, it's going to open up the passageway. The oil is going to start flowing through this, and then the pressure of the oil is going to open this switch. This switch is normally closed. Once the pressure is applied to a switch is going to open. It's going to send the signal to the computer, and then the oil is going to go to actually the camshaft, and then VTEC is going to work. But what we had a problem after I energized the solenoid through my scan tool, we did not see any changes on our input. So now these days it's very complicated and very time consuming to diagnose all these problems, and it's just one of the things that I always emphasize: you cannot ignore, just because if you don't understand how the switch works, you cannot ignore that part of it. You have to figure out, you know, what part of the system is not working. So this is the diagram of this part. This part of the diagram here is our input, and this is actually a control side of where the computer sends the power down to a relay, and the relay is doing actually the work. Our switch is normally closed. Computer sends 12 volts down to switch, and since switch is it's grounded, it's gonna pull this 12 volt down to 0, okay? And that's what computer was seeing in my case. So, which means a 0 volt. It was on my scan tool when I was watching my data. Live data. Computer was having on all the time. So, which means the 0 volts is on and 12 volts is off. That's what the computer is by seeing the difference in voltage. It actually puts this message on gives this message on your scan tool. So in order to eliminate, to figure out, you know, this part of the circuit, we need to understand, you know, how does it work. So the easiest thing, when you look at the wiring diagram, and when you see the switch here that is connected down to ground, that's our ground side switched, and it's called pull down design. In this design, for system to work, switch has to have some kind of voltage to come into switch. Okay, there's some kind of reference voltage, be 5, 10 or 12 volts, whatever. So there has to be some kind of voltage. If you don't see the voltage in your signal wire, if you see the 0 volts, and you have a 0 volts at the switch, 0, it's 0, it's never going to change. So the computer is not going to see any changes in a signal. So there has to be some kind of voltage on it. So how are we going to find out, you know, what voltage we're supposed to have in our circuit? So what I did, I went down to my switch. I get down to my switch, right there, and I unplugged it. I pulled my connector and I unplugged the connector. So basically what I did, I made an open loop. I disconnect my switch, and my voltage went up to 12 volts. So that is an easy test to test your signal wire. Okay, so once I unplugged the switch, and I also looked my data on my computer, and my computer was reading off at the time. So this tells me that my signal wire was okay. My computer is sending the signal 12 volts to switch, and also my computer is actually reading, responding to the signal. So reads 0 is on and 12 is off. Now, what we're going to do if we unplug the switch and we see 0 volts? And that is a red flag right there. Okay, you unplug the switch, but make sure you're on your signal wire. Okay, don't be on, if you're on the ground, you're going to have 0 volt no matter what. If you unplug your sensor and you T-pin you measure the voltage on your signal wire and you see 0 volts, that is your problem. Don't change the parts. You have an issue in you have a problem on your signal wire. Now, how we gonna address that? Now, there's two possibilities we could have. We could have short to ground, which means that our wire, insulation of our wire is damaged and the wire is touching the block somewhere and it's pulling this voltage down to 0. So somewhere along the way we have wire that's touching the ground. Now, if we have something like this, so now we measure our voltage at the switch, we have 0 volts. Well, next what we're supposed to do, we're supposed to go to our computer, find the computer, and we have to find the diagram and find the wire that gets connected to computer, and we're gonna make the measurement and take the voltmeter and measure the voltage at the computer. If we read 0 volts at the computer, we have short to ground. So what I do at that point, I unplug the computer. Okay, now the short can be, the computer could be shorted as well, or the wire can be shorted. So to address that, we need to unplug the computer and take the test light on either side of this wire, doesn't matter, take the test light, connect to battery positive, and if the test light lights, okay, if the test light lights, that means that you found the path, the test light, you complete the circuit. Somewhere along the way there is a short to ground and this test light lights. So test light is nothing but the light bulb, that's all it is. So now you know that just along the way you have a short to ground. Now if you plug in your test light and it doesn't light up, then you have a short to inside the computer. Your ECM is problem. I hope this makes sense, but this is what you need to do to address your short to ground. Now, how are you going to address an open? So you're down at the switch, you unplug it, and you read 0 volts. Again, you go back to your computer and you measure the voltage at the computer. If you measure 12 volts at the computer, you simply have an open somewhere. You have to trace this wire until you find an open and fix the wiring issue. In my case, also one other thing we can do, but one other thing also is, for me, is what's very frustrating is to find a good source of information. That is the hardest thing for me. You can Google it, you can until you really, that's the hardest thing, to understand, to read exactly what voltage the computer is looking at and how the system works, and once you read it, once you understand, then you can actually proceed to your diagnostic. Now, in my case, I basically had a 0 volts all the time and my computer was reading on my scan tool. If I when I unplugged my switch, I had a 12 volts, so I know it was fine. But if I would have 0 volts, and if I would have a on my scan tool, which means my computer is reading 0 volts, then I could possibly have a short to ground or short the computer. So I would address it as a short to ground. Now, if I would have a 0 volts at my sensor, but my computer is reading off, my computer is reading 12 volts, then I know that I have an open somewhere in a wire. And so I would just have to look for open. That will be easy as that. So again, if you have a switch that pulls something to ground, the ground side switch, okay, when you unplug it, you've got to have some kind of voltage coming from the signal wire. I have a video on, I'm going to put link in the description also, on the F250 they had a problem with the oil pressure gauge. It wouldn't move. It was actually, it's 96, it's older model, but its pressure switch send the power to, a cluster sends the power to pressure switch. Pressure switch was normally open, and once you start the car, when the pressure builds up, the oil pressure builds up, it closes the switch and actually pulls it down to 0. But when I unplugged my switch, I had a 0 volts. And I knew right there that's my problem. I have to trace that wire to see what the issue is. Change the pressure switch is not going to do any good, because having 0 and 0 equals 0. If you have a 0 at the pressure switch and you have a 0 on your sensor wire, it's not going to make any difference. It's not going to work. The computer or any module that looks the difference in a voltage, it's not going to see any difference, because it's going to be 0 volts either way. So, in that case, it was actually end up being a faulty cluster. So the owner still kind of looks for a used one. So we're still kind of waiting for that to be fixed. But now, so that's what I want to talk. The part of this input. So what input is doing, when computer commands something to work, needs to have some kind of feedback to know if something's working or not. Now, this engine also has a VTEC. It's variable timing. It's basically a phaser on the camshaft as well that changes the retard and advance the timing on it. So also it works on the oil pressure, but in this case, computer actually look at the input from a camshaft sensor to see if once they apply the oil pressure to it, wants to see the changes on the camshaft, on the camshaft sensor. So that's the computer always have to have some kind of feedback to see what is going on. And for us to diagnose the problem, we need to diagnose both feedback part as well as the part is doing the physical work, being a solenoid or injector or coil or whatever you work on. So now I'm going to part where I diagnosed a solenoid, and this is one actually that I really missed, something very important. And that's what you guys can do if you have a problem with this. What I did not say in my last video is actually you can check the resistance on this solenoid, and the spec for resistance is 14 to 30 ohms. So take your ohm meter and check resistance. Now it's a little tricky to get your leads because it kind of sits behind the engine block. You have to get your leads down and check your resistance. And if you see resistance, out of spec, then you know your solenoid is problem, and you can replace the solenoid. But also, you have to want to make sure that a computer is able to energize the solenoid, especially if the solenoid is shorted. If you measure maybe 1 or 2 ohms, the solenoid is shorted, and it can actually damage the driver inside a computer. So you still want to make sure that computer can actually energize the solenoid And of course, if you don't have the scan tool that can actually use if it has a bidirectional controls, it's kind of hard to do it. In this instance, you will have to actually take the car for test drive and get the voltmeter and look at the voltage, as you drive. When the computer energizes, sends the 12 volts to the solenoid. So I need to grab my ohm meter real quick, and I'm gonna talk about the resistance on this solenoid. Okay, so what I did to address my solenoid, and to address what I did, I used a amp clamp, and this is the part that I really didn't explain. Why am I using this? What was the reason why I was using the amp clamp? Why was I looking at the current in my circuit? The first reason is I was just wanting to see if once I command the solenoid to turn on, I wanted to see the current. To see if I see the current, then I know that my computer is actually able to energize my solenoid. But also I wanted to see how much current do I have through that circuit. Now, since I had a spec of 14 to 30 ohms, and when I was doing my testing, and this is the part that I really missed in my last video, this is what I want to explain. Having a 14 to 30 ohms of resistance on my solenoid, at the time when I was testing my solenoid, my system voltage was 14.3 volts, and if I divide my voltage with my resistance, my amperage was 14 to 30 ohms. If I divide it with my voltage, my amperage draw should be anywhere from 1.1 amp to 0.4 amps. Okay, so when I still actually have my waveform saved from that, and I'm really having a hard time with this camera to see on my. Okay. I hope you guys can see this, but this is the waveform that I saved from the. Let me get a little closer. Okay, so my yellow trace was my voltage. I also backprobed my control wire, and I was looking at the voltage, so I can see that I had a 14.3 volts as once I energized my solenoid, so I knew that I don't have any unwanted resistance in a circuit, and my ground was like 12 millivolts, so my ground was good. And as by seeing this square wave, the reason we see the square wave is because computer this is a pulse modulated system where the computer is actually kind of turning on and off really fast, and actually we can measure time in between, like this is let's see, like actually it's not going to give me the time, unfortunately. It's giving me a frequency. Actually, yeah, it's 0.3 seconds, I'm sorry. Right, yeah. Difference between the first number 2 and number 1 and 2, so it's a 0.3 seconds, so this is a 0.3 seconds between these pulsations. But so when so the green trace, I have 14.3 volts. That was good. Now my yellow trace is actually my amperage draw, and I had a 79 millivolts, which basically it's 80 millivolts, but my scale was 100 millivolts equal 1 amp, so I had a 0.8 amps of current through my solenoid, through my circuit. So well, this told me that Ohm's law, if I divide 14.3 volts, sorry, by 0.8 amps, I'm having a 17.8 ohms of resistance, and that would be in spec with for this solenoid. And this is something that I actually missed when I was making my video. So 17.8 of resistance, 7.8 ohms of resistance, that is in spec, and my spec was from 14 to 30 ohms. So 17.8 ohms, it was correct. But I'm gonna also measure resistance on my now. If you would see, if you do a diagnostic and you get, you check resistance on your solenoid, then you would know, if it's out of spec, that's your solenoid is bad. So let's just do the resistance real quick. This is in a shot. Okay. No, this is really hard. I mean, it's even harder when it's in a car. My leads are messed up. There you go. 17 point. There you go. So it's right on money. 17.61. There you go. You guys see that? Yeah. So and the amp clamp is not 100%, on this, but it's actually pretty close. I mean, so that told me right there when I was doing my diagnostic that my resistance on the solenoid was okay. But I still did not see any changes from my input switch. One other thing, this input switch, the switch is supposed to open at 57 psi of pressure, I believe. So we can actually test the switch as well. I'm gonna plug in my light bulb in series with this switch. I see my okay, so like you guys see, the switch is normally closed. My light bulb, it's lighting, and now I'm gonna take air pressure, and I actually put on 40 psi, a little less than what the specs are, and see, I'm going to apply the pressure on the switch and see if it's working or not. I can see, there you go. So the switch was actually sending correct signal to computer. There you go. And that's actually how you can test this switch anyway, but I believe you cannot. I don't know if you can buy the switch separate. I think it's just the whole unit you have to buy anyway. So one other thing that I missed also in the video, I did not, one other possible cause was actually clogged up filter here, and when I looked, it didn't look, I would expect to see a filter that's kind of baked, but I know it's dirty, but I don't think this would cause complete obstruction of oil through my unit. So then I decided to change it. At that point, everything that I could check, I checked, and I believe the issue is it's solenoid itself. Even though it has a correct current and all that, it's just not opening physically, So after we replace all this, it's working fine. So I think this is all I want to talk about. I hope I I hope I wasn't boring, and I'm not sure what else. Yeah, of course, for you guys who don't have the scan tool with bidirectional controls, you will have to take the car for test drive, but you got to have some kind of a scan tool that can read data on it. And before you take the car for test drive, you have to clear the trouble code, because computer will not turn the VTEC system with the trouble code active in the system. So you have to clear the code and take the car for a test drive. So I think that's all I want to talk about. I hope this makes sense. I'm sorry. I'm not sure what else I could. I think that's it. All right. Well, guys, thank you so much for watching, and please subscribe to my channel. Please leave the comments. Please tell me how I'm doing. What should I change? What should I improve? And thanks for watching. See you next time.